Hello and welcome to our next video on section 7.3, and we continue talking about sines and cosines, and this time we're going to talk about angles on an axis. So basically it's the angles, a 0 degree or 0 pi, 90 degree, or uh, pi over 2, 180 degree, or pi, or 270 degrees, or 3 pi over 2, and 2 pi. So these are the angles on axes. On x-axis we have 0, pi, 2 pi, so forth. And on the y-axis we have pi over 2 and 3 pi over 2, and also their multiples. Okay. Also, these angles are called quadrantial angles, just as a reminder. Quadrantial angles. Okay, so here's an example. We're going to start with an example. Find the cosine of 90 and sine of 90. So the first step would be to draw a unit circle, and then 90 is right here. So since our unit circle intersects x and y axes in points -1, 1 and -1, 1, we want to know the coordinates of this point. And since it is on the y-axis, the x-coordinate, actually, which shows movement left or right from the y-axis, is 0. Now the movement up or down from the origin is actually 1 step up. So the coordinates are 0 and 1. And that tells us, remember, in the previous video, we were saying that sine of t is y and cosine of t is x when referring to the unit circle. So therefore, the sine of 90 degrees is the y-coordinate, which is 1, and the cosine of 90 degrees is the x-coordinate, which is 0. Okay, so we answered this question. Now, I want you to answer the next question. Find the cosine and sine of the angle pi. I'll wait. And if you need a hint, pi, if you remember, by now you should. Remember that pi is 180 degrees. All right. So another fact that I want to bring to your attention is Pythagorean identity. In general, by Pythagorean theorem, we were saying that if we have a right triangle with legs A and B and the hypotenuse C, we have this relationship between all of those sides of the triangle. The sum of the squares of the legs equals to hypotenuse squared. Okay, so let's talk about how it applies to our triangles inscribed into a unit circle. Well, we know that here the coordinate of this point is x and y, right? Now we have a where x is cosine of this angle S, and y is a sine of the same angle. Now also this x is the side of this triangle and y is another side of the triangle. So we have, by Pythagorean identity, we have x squared plus y squared equals 1 squared, or just 1. But also recall that actually x is cosine squared of angle t, and y is squared is actually sine squared of angle t, and 1 squared is 1. So we do have this identity. It's called Pythagorean identity. It's one of the basic ones that you're required to remember. By the time you finish the course, especially, you are expected to remember this identity. This is the basic identity. And remember, like we said, even though we start with the unit circle to basically connect the coordinates of the point to the angle, to the function of the angle. Actually, those functions, the sine and cosine, are the same for any basically the circle with any radius. So if we were to extend this triangle, the sine value and the cosine value would be the same, and this identity would work as well. So this identity, it works not only for the unit circle, but it works for any angle and any circle. So it's a basic identity. Again, please remember it. How are we gonna apply it? Well, basically, if you know one function, you know the other function. For example, here we said they gave us sine of t equals 3/7. T is in the second quadrant. Find the cosine of t. Well, first of all, let's draw this angle. So we don't know exactly where it is, but we know that it's in the second quadrant. So we'll just eyeball it, okay? Here, I'm going to put this point here. And I know that the sine, or the y-axis, is positive, right? So this right here is 3/7, or this side of the triangle is 3/7. So I know that I'm going to start with that identity, sine squared t plus cosine squared t, and I put a set of parentheses. I don't know why. I mean, they could be there, but I don't need them there. So now I'm gonna replace what basically plug in the values that I know. So I know the value of sine is 3/7, and I'm gonna square it, because this says whatever value of sine is, square it, okay? Don't confuse it with 2t, or this is a square sign, and it means whatever the sign is, square it. Plus cosine square of t equals 1. Now I want to, so square 3/7 square would give me 9/49. Cosine squared t equals 1. So now I'm going to start solving for cosine. And in order to do that, I'm going to bring the 9/49 to the other side. All right, so these cancel out, and I have cosine squared t equals 1 minus 9/49. So on the side here, I'm going to do this fraction calculation for you. So 1 minus minus 9 over 49. First of all, I'm going to turn 1 into 49 over 49 and subtract 9 over 49. So that gives me 40 over 49. Okay, so cosine square equals 40 over 49. Now, in order to solve for cosine, I need to unsquare. But when I unsquare, I know that my result could be positive or negative, just like, for example, the square, if I'm unsquaring, unsquare 9. So if I'm unsquaring 9, I could get, there's two possible answers, positive 3 or negative 3, because 3 squared equals 9, and as well as negative 3 squared also equals negative 9. Positive 9, sorry, negative 9, positive 9. I was thinking, if you disagree with it and if you think that it's negative 9, then talk to me in after class or during my office hours or in class, up to you. So basically, when we are unsquaring this 40 over 49, we have to choose either positive square root or negative square root. And this is where this is our hint right here that will help us to decide. Because remember we said our angle is in the second quadrant, and in the second quadrant, cosine values are positive or negative. Well, if you remember that the cosine value is actually the x coordinate, so, and it's in this quadrant, they're actually negative. The cosine is negative. So I'm going to select a negative root of 40 over 49. So splitting that square root, the numerator and denominator separately, I'm going to get, well, again, let's do the calculations on the side. So here, square root of 49 is just 7. It is 7. Now, what about the square root of 40? Well, for the square root of 40, I'm going to split 40 as 4 times 10, and I'm going to square root each factor separately, and square root of 4 is 2. Square root of 10 just is irrational, cannot be simplified anymore. So it's going to be 2 roots of 10. So I'm going to have negative 2 roots of 10. So basically the answer is cosine t equals negative 2 roots of 10 over 7. All right, now I want you to try a similar problem by yourself. This time they're giving you a cosine of 24 over 25, and the t is in the fourth quadrant. Find the sine of t. So the fourth quadrant is right here. And a hint, x is positive here and the y is negative. So your cosine is going to be positive and the sine value is going to be negative. Let's go ahead and finish this problem and let me know if you ran into any kind of trouble. And this is it for this subheading, and I'm gonna see you in the next video.